Hello students, welcome back to our YouTube channel Geeks for Geeks Get Computer Science and Data Science. So in this video we are going to discuss about diagonalizability. So till last session we have discussed about eigenvalue, eigenvector and we have discussed about Cayley-Hamilton theorem. So in this video we are going to discuss about diagonalizability. So let's start first with the definition of diagonalizability. So I'll say that if A is a square matrix of order n cross n, if A is a square matrix of order n cross n, then I find out A is equals to PD P inverse. Then A is diagonalizable. Or you can write down the definition as, if A is a n cross n matrix and you are able to find out a matrix P matrix, you are able to find out n cross n such that P inverse AP is equals to a diagonal matrix. If it is a diagonal matrix, then it is diagonalizable. So either you can write down D is equals to P inverse AP, or you can write down A is equals to PD P inverse. Right? D is a diagonal matrix here. Right? So the definition of diagonalizability says that if A is a n cross n matrix and if I'm able to find out a matrix P such that I'll solve P inverse AP, I'll get a diagonal matrix, then A is diagonalizable, otherwise A is not diagonalizable. Then A is diagonalizable. So the question arises that how I am going to check the matrix is diagonalizable or not. So let's see with an example. So they are saying that a square matrix A is called diagonalizable if there exists an invertible matrix P such that P inverse AP is a diagonal matrix. Right? Let's consider this matrix. Let's first, so how do I find out this D matrix and P matrix corresponding to the matrix A? So what would we do? We'll find out the diagonal, first we'll find out the eigenvalues. So the topic is completely dependent on eigenvalue and eigenvector, this topic diagonalizability. So first find out eigenvalues. So if I'll take sum here would be 6. Sum of eigenvalues would be 6 because that is trace and product is determinant. So I'm just trying to find out quickly with a shorter method. Product would be 1 into 6 minus 0 minus 2 into 2 minus 2 into 0 into 2, 0. So 6 is a determinant basically. Product is 6. So what values I'll take? So that sum of the eigenvalues is 6 and product of the eigenvalues is 6. Can I take lambda is equals to 1, 2 and 3? If I'm able to do that, right? So this is a eigenvalues 1, 2 and 3. So what will be my diagonal matrix? Diagonal matrix would be 1, 0, 0. 0, 2, 0, 0, 0, 3. That means I'll take all the entries, all the eigenvalues at the diagonal entries of the matrix, and yeah, this is a diagonal entries and all other values are 0. So this is my diagonal matrix. Now corresponding to this, I have to find out the P matrix. What is P matrix? P matrix is basically eigenvector corresponding to each of the eigenvalue. So for that, what would I do? I'll find out eigenvector corresponding to lambda is equals to 1. Corresponding to lambda equals to 1, I have to find out an eigenvector. So what would it become? A minus 1i x equals to 0. I'll solve it. What would I get? 0, 2, 0, 0, 0, 3, 2 minus 4. Sorry, 0, 2, 0, 0, 2, 0 because I am subtracting identity out of it, and 0, 2 minus 4, 1. This is my matrix x1, x2, x3. If you need to row reduce it, you can do that, but I can directly get the answer. So 2x2 is 0, second row and first row both gives you 2x2 0, 2x1 minus 4x2 plus x3 0. And I'll take x3 as my free variable because there is no pivot entry. If I'll interchange this first row and third row, I'll get the solution. So x2 is 0. And x3 I am taking as a free variable. So x1 would become minus 1 by 2 x3. So what would be the eigenvector corresponding to eigenvalue 1? Can I write down x1, x2, x3? The eigenvector would be minus 1 by 2, 0, minus 1 by 2 and x3 is 1. So this is my eigenvector. Minus 1 by 2, 0 and 1. Now I'll do the same thing. let's do the same thing for eigenvector corresponding to lambda is equals to eigenvector corresponding to lambda is equals to 2. So let's do that. So what would I'll do? A minus 2i x equals to 0, right? A minus 2i is equals to 0. So if I'll solve this, 1 minus 2, that would be minus 1, 2, 0, 0, 1, 0, 2 minus 4, 0, x1, x2, x3, 0, 0, 0. So you can check that your x3 would be a free variable and this row would be 0. I am solving it directly, but you can solve it longer method to find out the value x1, x2, x3. So I'll get minus x1 plus 2x2 0, and on solving x2 is 0 and 2x1 minus 4x2, that is the same equation as the first one, that is linearly dependent. So x3 is free variable, x3 is free variable because x2 is 0, because of that x1 would be 0 here. So what would be the vector? x1, x2, x3. The eigenvector would be 0, 0 and 1. This is my eigenvector corresponding to lambda is equals to 2. Now I'll do the same thing for eigenvector corresponding to. Now I need to find out eigenvector corresponding to lambda is equals to 3. Let's do that. Eigenvector corresponding to lambda is equals to 3. क्या हो जाएगा ये? A minus 3i x equals to 0. So what it would become? I'll write down the matrix. 1 minus 3, minus 2, 2, 0, 0, 1, 0, sorry, 0, 0, 0, 0, 0, 0, 2 minus 4 minus 1, x1, x2, x3, 0, 0, 0. Now here if I'll subtract r1 minus r2 tends to r2 plus r1, what it would become? minus 2, 2, 0, 0, 0, 0. ये r3 आएगा, right? What it would become? 2 minus 2, 0, minus 4 plus 2, minus 2, and minus 1, 0, minus 1, right? x1, x2, x3, and right side would be 0, 0, 0, 0, 0, 0. Now I need to solve x1, x2, x3. That means I am finding out eigenvector corresponding to 1, 2 and 3. Now for 3, what would be the eigenvector? Minus 2x1 plus 2x2 is equals to 0. That means x1 is equals to x2. यहाँ से तो ये मिल गया. Minus 2x1, minus 2x2 minus x3 equals to 0. So x2 is equals to negative of 1 by 2 and x3 negative of 1 by 2 x3, right? So I got the eigenvector here x1, x2, x3. The eigenvector would be x1 would be minus 1 by 2 क्योंकि x1 x2 same है, minus 1 by 2 and ये 1 and this is my x2, x3. So I get 3 eigenvectors corresponding to each of the eigenvalue. Now what would I do? Now what would be my P matrix? So P matrix would be, so how do I write down? I'll write down the same order. In the same order I have written the eigenvalues corresponding to 1. What is an eigenvector? Minus 1 by 2, 0 and 1. Corresponding to 2, what is an eigenvector? 0, 0, 1. And corresponding to 3, it is minus 1 by 2, minus 1 by 2, 1. So this is your P matrix and you can write down, you can just check that simply by yourself. A is equals to P inverse dP or D is equals to P dP inverse. A is equals to P dP inverse, right? Or P inverse D, P inverse AP. ठीक है, you can check the definition. यही लिखी थी हमने definition. P inverse AP is a diagonal matrix. So P D P inverse, right? So that's how you got the matrix D and P. So the question arises that every time your diagonalizability exists, every time you can write down the matrix A into this form? No, that may or may not be possible. Why is that? Let's take one example here. I am writing one example here Let's say I am writing this matrix 1 1 0 1. I am taking a simple matrix to make you understand the concept, right? Let's say this is my A matrix, right? पहले एक छोटी different matrix लेके चलते हैं. A is a matrix 1 0 0 2 1 0 0 2, और let's say ठीक है, हाँ 1 0 0 1 आइडेंटिटी मैट्रिक्स लेके चलते हैं. आइडेंटिटी तो चलो म्यूचुअल केस हो जाएगा, कुछ और लेके चलते हैं. हाँ पहले इसको लेके चलते हैं, इसको आइडेंटिटी छोड़ो. 1 0 1 1, this is my matrix. Now I want to check that this matrix is diagonalizable or not. Previous matrix, this matrix which I have discussed, it is diagonalizable. Now I want to discuss about this matrix. Is this matrix diagonalizable? So what would I do? I'll find out the eigenvalues. Eigenvalues is equals to lambda is equals to 1 comma 1. Lambda is equals to 1 comma 1. So you would find diagonal matrix become, diagonal matrix बाद में लिखेंगे, पहले आइगन वेक्टर निकाल लेते हैं. आइगन वेक्टर corresponding to lambda is equals to 1. If I'll take lambda is equals to 1, what would be the eigenvector? A minus 1i x is equals to 0, right? That means 0 1 0 0 x1 x2, that would be 0 0. So x1 is your free variable, x2 is 0. So that means what is the eigenvector? x1 x2. So x1 is free variable, so it would become 1 0, and that is x1. That is your eigenvector. But can you see that what you do? You would write down the diagonal matrix as, what is your diagonal matrix? Diagonal matrix you would write down as eigenvalues at the diagonals, right? This would be your diagonal matrix. But when you try to write down the P matrix, you get only one vector as an eigenvector, but you do not get another eigenvector. You are not getting another eigenvector here, right? You do not have an eigenvector. So that means, can you say that when you do not have enough eigenvectors, then enough linearly independent eigenvectors as a order of a matrix, then the matrix is not diagonalizable? So here this matrix A is not diagonalizable, not diagonalizable. So can I write down some of the points? Can I write down some of the points? A is a n cross n matrix. A is a n cross n matrix. Then it will, एक minute. Just a minute, guys. A is a n cross n matrix and it will be diagonalizable. It will be diagonalizable if it has n linearly independent eigenvectors. N linearly independent eigenvectors होंगे, then it will be linearly independent. अब इस केस में देखो, we have order of the matrix is 2, but we are getting only one eigenvector, so that's why it is not diagonalizable. Can I say one more thing, that if A is of order n cross n has n distinct eigenvalues, so one thing I know, that if A n cross n has n distinct eigenvalues and for each of the eigenvalue there is at least one eigenvector, एक eigenvector तो होगा हर एक के लिए. So we'll have n independent eigenvector. If A is a matrix which has n cross n distinct eigenvalues, then A would always be diagonalizable. A is diagonalizable, so you do not need to check it. Diagonalizable, right? So like now the question arises that whenever I have a repetition of this eigenvalue, whenever we have this repetition of this eigenvalue, then we do not have any we do not have the eigenvector, we do not have the matrix diagonalizable. This is a question arises, but that is not true. ऐसा नहीं है कि repeat हो रही है, हमको independent eigenvectors मिलने चाहिए. दो एक example लेते हैं. 1 0 0 0 1 0 2 3 5. This is an matrix A. I want to find out, इसको ऐसे लिख लेती हूँ, 2 3. This is my matrix. A is a matrix. Now the eigenvalues of this matrix is, because this is upper triangular matrix, 1 1 5. This would be my corresponding to 1. इसको 0 ले लो. इसको 0 ले लो अभी, ठीक है. 1 0 3 मैंने ये लिया है. This is a matrix I have taken. I just want to check that is it diagonalizable or not, because it is a upper triangular matrix. Eigenvalues would be 1 1 5. So here I am interested in finding out eigenvector corresponding to eigenvalue 1, right? Eigenvalue 1 के corresponding. So a minus 1i x equals to 0. What would it become? 0 0 3 0 0 0 0 0 4. So if you would check here, you have two free variable x1 comma x2 are free variable. Why? Because we do not have any pivot entry, और ये 4 तो 0 हो जाएगा if you would apply row reduced. So on solving I got x3 as 0. x1 x2 are free variable and x3 is 0. So can I write down this vector as x1 x2 x3 would be x1 x2 0. And how do I write down the solution as an independent number of solution? क्या बन जाएगा? 1 0 0 x1 and 0 1 0 x2. Now what is happening? 1 is repeated here 2 times, but corresponding to 1 I get the eigenvectors. 1 is repeated 2 times, but corresponding to 1 I get the eigenvectors. अब एक छोटी सी चीज़ और देखते हैं. eigenvector, अगर 1 दो बार रिपीट हो रहा था, if I get 2 times eigenvectors, 2 eigenvectors corresponding to the eigenvalue 1, then that is enough, because one vector I get corresponding to 5. So I'll have 3 eigenvectors and 3 eigenvectors, and that means I need 3 eigenvectors for the 3 cross 3 matrix. So it would be diagonalizable. चलो, बट एक बार चेक कर लेते फॉर्म क्या होगी. If they are asking for diagonalizability, I can stop it right here. If they are asking what would be the form, what is P and D matrix, then you have to solve it further. Eigenvector corresponding to lambda is equals to 5. So a minus 5i x equals to 0. What it would become? Minus 4 0 3 0 minus 4 0 and 0 0 1. We get this matrix x1 x2 x3 0 0 0. Right? This would be my matrix. Now I'll solve it. Already in row reduced format. Minus 4 x1, I think minus 5 sorry, this would be 0. Because why I know that this is not true? Because to get an infinitely many solution, at least one free variable should be there. So minus 4 x1 plus 3 x3 is 0, minus 4 x2 0, and x3 is what? Free variable. So what is your solution? x1 x2 x3, that would be your x1 is 3x3, x2 is 0, x3 is same. So I got 3 0 1 as my eigenvector. So what I want here, I want P and D matrix. So P matrix, D matrix would become 1 1 and 5, right? 0 0 0 0 0 0. This is my diagonal matrix. And later on for P matrix, guys, you have to keep the order same. 1 is repeated twice, 1 is repeated twice, so either I can write down 1 0 0 first or 0 1 0 first, so it's up to me. 1 0 0 0 1 0, मैं कोई भी order लिख सकती हूँ, it's up to me. And for Y it is 3 0 1. Now I can say that A is equals to PD P inverse. These two are the matrix. So if there is a repetition of an eigenvalue, how many times our eigenvalue is repeating, that many times should be the eigenvectors I'll get. So there is two terms which you need to remember, that is algebraic multiplicity. I do not remember if we have discussed it before, but you have to remember it. Algebraic multiplicity and geometric multiplicity of lambda. So algebraic multiplicity is how many times your eigenvalue is repeating itself in the eigenvalues. How many times? Number of times lambda is repeating itself. That is your algebraic multiplicity. Geometric multiplicity is number of eigenvectors I get corresponding to the eigenvalue lambda. Number of eigenvectors corresponding to lambda. Right? That is the definition of geometric and algebraic multiplicity. Now, the last point which you need to remember is, for A matrix to be diagonalizable, for A matrix to be diagonalizable, algebraic multiplicity should equals to geometric multiplicity for each or for every eigenvalue lambda. कुछ भी लिख लो. For every eigenvalue lambda. If this thing happen, then you would say that your matrix is diagonalizable. Otherwise, matrix is not diagonalizable. Now, one thing you can notice here is, one is occurring, algebraic multiplicity of 1 is 2, and I get geometric multiplicity is 2. 1 is occurring 2 times and geometric multiplicity is 2 because it is eigenvector, number of eigenvectors corresponding to 1 is 2. Algebraic multiplicity 2, geometric multiplicity 2. For 5, algebraic multiplicity 1, geometric multiplicity 1. That's why I got this matrix A as diagonalizable. But in the previous case, in this case, when I have said that here geometric multiplicity, if I'll write down here I got geometric multiplicity, algebraic multiplicity of eigenvalue 1, it is repeating itself 2 times, and geometric multiplicity I have only 1, because these two are not equal, so that's why matrix is not diagonalizable. Otherwise matrix would be diagonalizable. Right? Same thing written here. N by n matrix is diagonalizable if it has n distinct eigenvalues. So there are some points written here. I think same points are written, which I have already write down. Now, rank of a diagonalizable matrix. कुछ important point लिखा, ये तो देखो same ही definition है. These 2 points we already have discussed. You can read that. A n cross n matrix is diagonalizable if and only if A has n linearly independent eigenvector. A is equals to PD P inverse. D is a diagonal matrix if and only if columns of P are linearly independent eigenvectors of A. This is true. In this case, diagonal entries are eigenvalue of A correspondingly to the eigenvectors in P. Okay, that is the definition. Now another point is rank of a diagonal matrix. Rank of a diagonal matrix is equals to number of its non-zero eigenvalues. Jitni bhi, because what would happen for a diagonalizable matrix? Rank of the matrix A would equals to the rank of the matrix D. And rank of D would become with the number of non-zero eigenvalues, because I am substituting that non-zero eigenvalues at the diagonal entry. Now they are saying that A is similar to B. Now guys, there is one more definition which you would remember. Diagonalizable is a bigger case. Similar matrix. Similar matrix. A and B are called as similar matrix. A and B are called as similar matrix if there exists a P matrix of order n cross n. There exists invertible matrix P. Invertible matrix P such that B is equals to P inverse AP. Now there might be a possibility that A or B are diagonal or not. So diagonalizability is an added point कि हमारा जो B होगा that is diagonal matrix. But if B is not diagonal, then what would happen? A and B are similar matrix, right? So A and B are similar matrix, so I can say that A is similar to diagonal matrix. This is a sign of similarity. A, if I am able to write down P inverse AP is equals to D, so I can say that A and D are similar matrix, right? Because here I am getting a diagonal matrix, that is one extra added point. In this, B is not a diagonal matrix, so we say that similar. If it becomes diagonal, so we say that it is diagonalizable. A and B have same determinant. They have the same determinant, same rank, same trace, same characteristic polynomial, and same eigenvalues. So you can see that it would be like this. Converting it to a diagonal matrix or getting two similar matrices is really good, because what would happen if I know all the properties of first matrix, I'll be able to get all the things for second matrix as well. So this diagonalizability process is helpful to working on most of the important points of a matrix, because sometimes for the same matrix I'll not be able to find out everything. If I'll know that it is similar to diagonal matrix D, working on diagonal matrix is comparatively easier, right? So that's why we have these properties, and that's why we are converting it into a diagonal matrix, right? This is one of the question. Let's try this question. Everyone will try. What is saying? Which of the following statement is /r correct? If A and B are diagonalizable, then A transpose is diagonalizable. Sum A plus B is diagonalizable. K identity plus A is diagonalizable. A to the power n is diagonalizable. A to the power n is diagonalizable. So let's check the definition. So A definition is PD, P inverse. Right, if it is diagonalizable, so if I'll take a transpose, so it would become P inverse transpose, D transpose and P transpose, P inverse transpose. तो इसको मैं ऐसे लिख सकती हूँ. Can I write down this as P transpose inverse and D transpose is D, P transpose I can write down. So I get a P matrix, that inverse of this matrix D into P transpose, so it is diagonalizable. They are saying sum A plus B is diagonalizable. So we know that every diagonal matrix is diagonalizable, right? Every diagonal matrix is diagonalizable. It is diagonalizable. This is A matrix and this is B matrix, -1, 0, 0, -1. So if you would take A plus B, it is not diagonalizable. It is not diagonalizable. Right, so B is incorrect. Now Ki plus A को यही रहने दो, K is equals to -1 ले लो. So A plus Ki would become 0, 0, 0, 0. Again it would not be diagonalizable. Zero matrix is not diagonalizable because we have eigenvalue 0 and eigenvectors we do not have any non-zero vector, so not diagonalizable. It is also A plus B you would getting here as 0, 0, 0, 0. राइट, सो इट इज ऑल्सो नॉट डायगोनालाइजेबल. नाउ ए टू द पावर एन की अगर हम बात करें, ये ऑप्शन ए के लिए बात की, यहाँ पे बी के लिए, सी के लिए, and here I am talking about D option, A to the power n. So it has this property, you can write down P D to the power n P inverse. If A is equals to P D P inverse, so power of A would become D to the power n, nothing else you have to do. So it is also diagonalizable. So option A and D are my correct options here. So A and D are my correct option, right? So we have added one question here. Guys, let me know this question's answer in comment section. right? Try this question by yourself, right? I have added this question file, otherwise you can take a screenshot as well, right? So let me know the answer for this question in the chat section. So these are all the topics we have in linear algebra. Now moving further, we are going to start calculus, but till now I think we have 14 lectures in that, so it is around 7 hours content. If you would go through that and later on solve the previous year question, I have added some of the previous year question here. I have solved it with you, but some of the questions you can just solve it by yourself by downloading the gate papers, and you would realize that these concepts, with all these concepts, you are able to solve all the linear algebra question. Okay, so yeah, that's all for this video, guys. All the best. I hope you have learned from this whole playlist of linear algebra. Thank you, guys. Thank you for joining. And yeah, that is the last slide. Thank you.